Hi, welcome to our video presentation on the paper titled A Comparison of Language Modeling and Translation as Multilingual Pre-training Objectives. Pre-trained language models like BERT have significantly advanced natural language processing across various tasks. However, best practice for multilingual pre-training remain unclear due to inconsistent training data, models, and evaluation methods for cross-country research. In this study, we compare two pre-training objectives, language modeling and translation, to identify optimal approaches for multilingual models. We focus on two factors, model architecture and pre-training objectives. We intend to address two main questions. First, does the explicit cross-lingual training signal of translation objectives foster better downstream performance in monolingual tasks? Second, is the optimal choice of architecture independent of pre-training objectives? In our pre-training, we use two datasets, the UMPC and the open subtitle datasets, covering 6 languages, Arabic, Chinese, English, French, Russian, and Spanish. To guarantee our models are trained on the same data, whenever a document is available in multiple languages, we greatly assign it to the best represented language pair thus far and discard all other possible language pairs where it could have contributed. We then discard documents where cannot be used as bytext. This ensures that all documents are used exactly once for both document level and bytext level pre-training objectives. To allow a systematic evaluation, we train the models with various neural network architectures and learning objectives. We consider both double-stack models and single-stack models. The two double-stack models are variants of the BOS architecture. They are trained either on a straightforward machine translation objective using language tokens to distinguish the source or on the original denoising autoencoder objective. We refer to these two models as 2MT and 2LM respectively. We also consider three single-stack models. MLM is an encoder-only model trained on the max language modeling objective. CLM is an autoaggressive causal language model, and the TLM is an autoaggressive model trained to generate a sentence, followed by its translation in the language specified by a given control token. The evaluation encompasses both sequence level and token level classification tasks using datasets tailored for sentiment analysis, named entity recognition, part-of-speech tagging, and natural language inference. The evaluation of the models involves two distinct experimental approaches to test the performance, probing and fine-tuning. In the probing experiments, only the parameters of the classification heads are adjusted. This method primarily tests the raw capability of the pre-trained models embeddings to adapt to specific tasks with minimal parameter of changes. Conversely, in the fine-tuning experiments, all parameters of the models are adjusted. This approach allows the entire model to adapt to a specific task, potentially leading to higher performance. Our results show that 2MT, which is pre-trained with the machine translation objective, consistently outperforms 2LM, which utilizes a denoising objective. And this pattern is consistent across all languages tested after fine-tuning as well as probing. Turning to single-stack models, we find a more complex picture. In probing context, we find the CLM to be most always effective, except for NAR in 5 languages and NAR in Arabic, while it performs slightly less favorably compared to the MLM. As for fine-tuning, well, the MLM generally ranks first on all POS, NER, and NAR test datasets. The TLM is usually effective for SE task. So to summarize, the translation objective provides a strong cross-lingual training signal, particularly in double-stack models where source and target languages are modeled separately. However, during fine-tuning, this advantage diminishes with single-stack models like mask language model becoming more competitive, especially for NER and POS tasks. So overall, the 2MT model delivers the most consistent and robust performance across all tasks and languages. In contrast, Single-stack models exhibit more variability due to significant fluctuations across different scenes. Thanks for watching.